From okay. Good morning. From 5.
Good morning.
Let's go. Last week, this week on Monday, we did some 3 questions. We did sign, cos, and tan. Now you have 3 more remaining. Did you work out codes?
No, teacher, we got stuck.
On code?
I got
stuck. Also got stuck.
Okay.
Even sick.
Okay, fine, no problem. Now, to differentiate code, again, you let your y be codes of x. Now, shall get y plus change in y given to codes of x add change in x. Like that, when your change in y becomes code of x plus change in x minus y, but your y is called x. Then you come and convert code in terms of sine and cos. Meaning change in y becomes cos of x plus change in x divided by sine x plus change in x minus cos of x divided by sine. Then you get the LCM. Change in y becomes cos. Now here, it's where the problem came from. You have to begin with sine instead of cos. When you are getting, you're multiplying by the LCM. Now sine. So you have to begin with sine. It should be now sine of x. This one first, then multiply by cos of x plus change in x minus sine of x plus change in x multiply by cos of x divided by sine of x, add a change by sine. Now, first look at that part. Now here, you guys, I think for you began with cos instead of sine, right? Now, look at your numerator, it's a compound angle, which is, if you compare this with sine of A minus B, you people, are you there?
Yes, we are there.
Yes, teacher.
Yeah, but I think this is where the problem came from. What did you begin with after getting the LCM? Did you begin with cos or you began with sine?
We began with cos.
Yeah, that's where the problem came from. Now you have to begin with sine. Okay? Because you don't have any identity, any compound angle of cosine sine. That would be sine and cos. So you have to begin with sine, then multiply by cos. Therefore, now your numerator becomes our change in y will be now equivalent to sine of x minus open a bracket x plus change in x divided by sine of x plus change in x. Do you have that? You see that?
Teacher, we have seen.
You see, okay. Now this is your A, this is your B, which is B A minus square of a negative, compound angles. But this should be in a bracket, that negative get us for X and a change. Now when you simplify, this is what you get. You have change in Y given by sine of negative change in X divided by sine of X plus the change in X, the sine of X. There's a negative. This X will go have a negative change.
Excuse me, teacher.
Yes.
Excuse me, teacher.
Yeah.
Teacher, that very last part, from our left-hand side, the very last statement we had, where we had our compound angle.
Yes.
Would it be fine if I started with my cos, then I put sine at the end?
To be wrong, it won't be correct. Because you don't have any compound angle beginning with cos and sine. You don't have it.
Okay.
Right?
Yes, teacher, it's clear.
Okay, fine. But you have a paper, Munduru, that's Chiduma.
Yes.
It up Munduru. Cut this Munduru. Yes.
Paper.
Munduru, I was signing you. Serena Gomez. Cut they go.
A real man.
Atimato. Samato. They are waiting. I will score daddy mean now. You can take him a math. Daniela.
Teacher, you're obstructing.
I'm assigning people. Hey, you are copying. Fiona.
Yes.
If people can't go, then Lenny. I don't know Daniel winner. And there are many. Rashida.
Teacher, some people breakout rooms.
They don't know.
Teacher, some people's breakout rooms don't work.
Yeah,
They
some
don't.
of them don't have that.
They should buy better phones. May I go to my iPhone?
Teacher, no.
Which iPhone? Stop lying. It's COVID that you bought. Be there.
Which iPhone? I bought my iPhone. You wait. Aren't you coming back on what? Saturday you see it?
No, just face COVID that you bought.
We are not coming back now.
Coming back. You have my paper on. You'll be there.
We have papers
Yeah,
that
we shall have network issues.
It's all definitely to come back.
Hey,
We are still in the village. To come back.
who's called the Beauty Beach?
That's one more.
Yes.
Serena, Beauty Beach. You, eh?
She does math.
That's math.
Class.
Okay, now, but you people, are you reading?
Yeah, we are reading.
We are reading.
Okay, I super many. Let me just teach you my money, right? I'm
You
taking
just
the time.
invite all of them. The ones who want to join.
What
All of them. The ones who want to join.
Let's continue. My number of deco. Now we are here. Now this negative, I'm going to factor it out to put it here. It's negative on the change. Take it out. Shall change in y. Give a negative sign of change in x. Divide by sign of x. Add a change. Now you come and make the assumptions, right? The first one shall, first divide by change in x. I'll change in y. Over change in x. Give a negative sign. Change in x. Divide by sign. Multiply by 1 over change in x. Now you come and make the assumptions. Shall say as change that you do. 10 to 0. The change in y by change in x. And dy dx. The actual gradient. The sign of change in x becomes the same angle change in x. And the sign of x plus change in x becomes sign of x. Therefore, come back and simply let's be dy dx. Prevent negative change in x. Sign of x times sign of x. Prevent 1 over change in x. What's the question?
Teacher, what if the cos was a negative? What happens to the negative sign? Like how you say that sign is a negative, the negative comes to the front. Then what if it was a cos which was a negative?
Yeah, that's a good question. Cos of a negative is the same as the cos of a positive angle. Cos of negative A is the same as cos of positive angle. Always make it a positive, okay?
Yes, teacher.
Always a positive. You're welcome. Now you have dy dx equivalent to, this will go up negative 1 out 12. N squared x, which becomes negative cos x squared x. So differentiate code to get negative cos x squared. All right, you can write, you can copy. Yeah, I say real math. Now that we are doing real math. Did you complete the work? There are 2 questions. Okay, any question? I'm stuck in my break. Wanji?
So the question I asked last time, you answered, but when I look into the book, it's like when we open up sign a minus b, we actually have a cos beginning. So I'm really confused.
Sign a minus b have a cos beginning.
Yeah, when we in the back house, when you open up sign a minus b,
you have
we get sign
beginning.
a cos. Yeah, at the end.
At the end, it's okay, but what I mean the beginning part. At the end, you can interchange. But
that was okay. That was my question. At the end,
at the end, okay. At the end, you can interchange, no problem. But I mean the beginning part.
Okay.
You're welcome.
Thank you.
You're welcome. Okay, now you get negative cos x squared. Let's continue. We go to part E. Can I remove
So we are
this?
still copying.
Okay.
So wait.
Okay, I'm waiting.
I'm gonna remove your screen thing. What's it about?
Remove what? When are you going for shopping?
We don't.
So you want to take us?
No.
So you want to buy for us?
Let's
Give us money.
I want to give you money.
We don't mind if you want to take us.
I I'll give you.
That's okay.
As long as you can get shop from, what is it called, the new shopping mall?
Which one?
Near the ski hotel.
Which one? You better know its name.
You don't
Sis-
know Medina. Where are you?
We are told.
In our homes.
You want me to give it passport, come to Kampala. Some of you are very far from Kampala.
Yes. If you are doing transport, please.
Ah, there I
To just cigarette, okay.
Now we go to part D. Part E, right?
Yeah, it's part E.
Let me remove this part here. We go to part E. Iman, Matub.
Yes, teacher.
Yeah? Yes?
Yes.
Who's calling me?
You said Iman Matov.
Hey, Iman, how are you, Iman?
I'm okay, teacher. And you?
That's a,
Zion,
that's
all
the
people on
name
the platform. Teacher.
of all people.
It's okay.
She's the class captain. For you, what's the role in class? You
I
understand?
tell what don't we do? We do
to
your work.
study and pass.
I know. We do all your work. What more do you want?
You do all my work. Why is the class captain? She gets the chore, she does the cleaning, the chore.
Whatever. I think now we do work. As you didn't call Anyoda. Why you didn't call Anyoda? Why you didn't call when you're edgy? Sure.
Hey, even Anyoda.
You
You don't even know what Anyoda is, Betty.
But how are you? The teacher keep quiet.
Sure.
Anyoda, how are you? It's Anyoda.
I'm fine, teacher.
You're good.
I'm here.
Oh, yeah, I can see you.
Yes.
How are you? Okay.
Yes, teacher, I'm fine.
Now, which part are you going to do now? We are going to part. Which one should we do? We have two remaining. I'm doing one, you also do the last part, right? Okay, part E, it says, shall let white be set, and then white plus change in y, this set of x add change in x, like that. Our change in y becomes x plus the change minus y is x. And change in y would be, you convert that to 1 over cos minus 1 over cos x. In the LCM, should be cos of x minus change in x out of now again you come and apply factor formula. Negative minus cos of x minus negative, you know what to do. Yes. Aren't you? Right? Wow. Okay. Now change in y becomes negative 2. Sorry. Factor formula. No. This one. So yeah, what we have here? Factor formula, If people what required. Yes, you have
Negative
negative 2 sign. You first add, okay? Of 2x plus change in x, right? Divide by 2. Then sign again. When subtract, just get change in x out of 2.
Yes.
Out of x plus change in x. You know that. Yeah, negative change in x. Yeah, right. Out of 2. Now, here I want to divide by change in y. Change in x. After change in y by change in x. Negative 2 x as change in x of x plus change in x out of 2. This negative, when you take it out to make this a positive quantity, to make a positive quantity, negative, and take this negative out. It's been a positive 2 now. X and change in x out of 2. Out of cos of x plus change in x. And cos of x. Then you multiply by 1 over change in x. Come and make your assumption. You say as change in x 0, a change in y over change in x becomes dy dx, the actual grad dx. Then the sign of x, changing x out of 2 becomes sign of x. Sign of changing x out of 2 becomes changing x out of 2.
Excuse me, teacher.
Yes?
So where do we get the negative from in the left-hand side?
When you subtract, remember we first add, then you subtract, have negative, it's become a negative. This will go, this will be a negative, open the brackets. Right?
Oh. Yes.
We first add this quantity, add the b plus a. This is what you get, 2x plus changing x over 2. Then subtract.
What is meaning?
You mean this negative, you mean this negative 2? Eh?
Yes, teacher, actually, you say the negatives cancel out from up there.
Yes. Because I have a negative and a negative out, which you give, it's a product you're multiplying. Then this dy dx becomes 2. There is what? Which becomes the 2 will go change, you go get sin x out of cos x and with cos of x to become okay, any question? That's what you get. Now I'm waiting for your questions. If you have any. So in differentiate sec, you get tan x sec x. Or sec x tan.
First way to
Teacher, Mr. Semakula.
Yes.
So now, if you like said it in a different way, for example, there I continued as like sine x out of sine squared x, then I write sine x sec squared x.
Oh. Okay, but this is the best way. That would be correct, but this is how you conclude. You get sine over cos and 1 over cos to be tan sec. This is what we want.
Thank you, teacher.
Though that is okay, but the best way to conclude.
Excuse me, Mr. Semakula.
I'm here.
Excuse me, teacher.
Yes.
Teacher, why don't we say cos x is a 1, just as the limits was stating?
We always say what becomes 1 is cos change in x. This one becomes 1. This change. But here we are adding x plus the change. This will be now a still and only get this. Okay? Here. This will turn to cos of x. Doesn't become 1.
Teacher, what is meaning? Even make us give it. The other cos x.
Which one?
The other one. The second one, the part of land with the change. Cos x.
I'll always state when change. When it's a change, that's what becomes 1. Small angle. These are remains. So the x is what becomes 1 and when it's a change. Change. But we assume that angle, the change will be
Mr. Semakula obstruction.
from me. What you want down?
Even on Zoom, they say you are obstructing.
You do the last part. Work out the last part, okay? And you have you had?
Yes, teacher.
I know that.
Yozi.
Where are you people? Where are you whatever? You call them what?
Best friends.
Now, how many?
Excuse me, teacher.
Huh?
I have a question.
What? What's your question?
Why is it negative?
What's the question?
That's
Here, negative.
on your left. Yes. Where does the negative come from?
And when you apply factor formula, you have cos A minus cos B is a negative 2. The cos a negative 2. When you come back to school, we shall prove that. I think I should prove for you that part, but it's a negative 2, okay? So constant, you have
like,
cos minus cos, a negative 2. Factor formula.
Teacher, no, not that part. Listen, in the first bracket, it's a plus. Then the next one, it's a negative. But I thought negative x, x minus x is 0. Then, there's a positive with the change.
It's like this. We have x. Look here. We have x minus x plus change in x. Put a negative. This will go and have this negative remaining. Okay?
Oh, okay.
And this time we have 2 terms. This side. There are 2. The negative affects all the 2 terms.
Okay, teacher. Thanks.
Okay, you're welcome. Okay, do the last part. Differentiate cosec. Have you had? Everybody. The 110, okay. At least 109, five and me.
Subtraction.
But you girl.
So we want to see.
Okay. Come on. Be that.
Excuse me, teacher.
Mm-hmm.
Teacher, where did the negative go? Because we had -2 sine x.
There's it's negative here. Sign of negative 10 is over 2. Factor formula, you first add, then you subtract. Right? Let's go that way. Let's do math. How about D? Who's called D? D? Julian. Should be in my mind. Good. You how you call D?
Teacher, she does math.
Julian. And she's hearing, but can't you talk, madam?
Excuse me, teacher, what's that last thing you've written down there?
Down where?
On the board where it's tan x sec what?
Sec. 1 over cos, we get sec.
Okay.
X, okay? Yeah, sine over.
Yes, teacher.
It's like this. You have this now. You have sine over 1 cos into 1 over cos, which becomes tan.
Tan x.
Then sec. Huh? That's what we have. Work out the last part. Hope you work out that question.
Yes.
Work out the last part and tell me what you get. That's your assignment, number 1. I'm giving you only 5 minutes to be done.
I have an answer.
Oh, what do you have?
I have negative cot x cosec x.
Yeah, that's very correct. That is for Becky. I want you post the same. I want to see. Eh? Who was talking? Who gave me the answer?
Angela. Pen.
Angela?
Tracy. Pen.
Angela Tracy. Okay.
Yes. Pen.
How are you?
I'm fine, teacher.
But boy, since you're in the village, until very far, your network is not very clear. That's correct. Where are you?
In Kampala.
Which side of Kampala? Kawempe?
In Chikubo.
Chikubo, didn't call her for you. I said, don't work, you are here studying. Need this girl, right? Aisha, Namudu.
Yes, teacher.
How are you?
I'm fine.
What have you got?
I'm almost done.
Okay, finish up. Appeal, Letitia.
Negative. Teacher, you're obstructing.
Easy again. Finish up and read. Hey, I'm teaching again on Monday. Even Wednesday. Even Friday.
When shall we show?
You want to? Hey.
It was the last week.
You want to go? You can shop over the weekend. This weekend go for shopping.
Just some of our places are filled with soldiers, and our parents are refusing us to go out. So,
In Magere, we have soldiers.
Just some of are just still in Eid mood.
Eid mood.
even didn't call us to come food. Shame on you.
Yeah, you find your Eid at school. I have it.
You have it.
The person who will come to me.
That's being selfish. If you're to give, you give. Don't put conditions.
Now you want me to look for you. I said the first 10 people, and you can't just look for me.
Teacher. Teacher.
Wanji?
And my answer is negative x cosec x. Is it correct?
Negative?
Cot x cosec x.
Negative what?
Negative cot x cosec x.
Yeah, that's correct.
Okay.
That's correct. Is Rania there? Edgar.
Yes, teacher.
Now you can be quiet. I have to see a number.
Not yet.
Not yet. Finish. Kalonji. Lucy told me, I saw writing that why she's tired.
Teacher,
Huh?
I have a question.
What's the question?
In the limits, there's a part they said, like the sine of the angle is equal to the angle itself, not so?
Yeah.
Now, why are we saying sine x is equal to sine x? Why isn't sine x equal to x?
We are only looking at, I told you, we are measuring change in x. This is a small angle. Very small angle measured in radian. They change only with not x. The two are different. Change in s and x are different. It's the angle we're looking at, which is tending to 1. The same angle, the side of the change. Side of this change. What tends to change? The same angle, right? Not x. This one is measured in what? In radian. This is a very small angle. The change, small increment. No, this is a very big angle, x. Right?
Yes.
Only the change in x, which is tending to this, not x. Are you following?
So if the change in x is considered to be an angle, then the x is considered to be what?
We are looking at small angles. When it be a small angle, it's a very small angle, not an angle. Okay, a very small angle measured in radian is the change. This s is not measured in radians. It's only the change which is measured in what? In radians. Are you following? The small increments. It's a very, very, very small angle measured in radians. The change in x, not x. Even when I was beginning the topic, I wrote change. I need to write x. Okay?
Excuse me, teacher. Excuse me, teacher.
Yes.
Where did the negative go on dy dx?
The negative.
Where did the negative go?
After applying factor formula here, after subtracting, it's a negative here and a negative here. Negative is a negative, make it a positive. There's a negative here on the change in x.
Yeah, that's your friend.
Funny.
No, Lillian. Lillian.
Yeah.
Just this year. What's that? Auma.
Teacher was not around. I've just connected. Don't blame me.
I'm not blaming you. I'm not. It's not me.
Teacher?
Yes.
What do you mean? That sine x is considered to be like sine x plus change in x. Is it in the limits? Is it where is it? Does it fall in that bracket? Because in the limits you don't have sine x only. So does it fall in the brackets of sine x plus change in x?
Sine x does not change. Always be like that. Even cos x, they are not affected because they don't have anything like changing x. Okay.
Teacher, also tan in x.
Even tan x does not change. What changes on the tan of changing x, sine change of x and cos changing x, or when you are adding the increments which will go to 0. How far with my question? Have you finished the number?
Yes.
Okay, I'll go to Rebecca. Okay, now let's have a summary of what we've done, and I give you work. I'm giving you 100 questions.
When shall we do them?
Eh?
When are we going to do those numbers? So we already have 56 statistics numbers.
You write summary where you do the numbers. DDX. Here we got a cos of x. DDX of cos of x. Not negative. Like this one should be in your head. On coming in there, I'll be at the gate. I'll ask you, differentiate what you get. If you fail, you go back.
Teacher, don't bring Kajanja.
You wait.
Shalom.
Of time, you get 6 squared. 4, when you differentiate codes, get negative cos x squared. This one should be in your head. Five is x over sec. You get sec x and x. 6 dx of sec. Negative cos x. X.
Teacher, so what do you mean every other thing rotates around that?
Now, that's a summary of what we have just looked at. I was saying this work should be in your head. Make sure you know it. We've done it, we've talked. Can I remove this? Now, let's look at examples. The first one, just say part A. If we share the following. Respect x. Roman 1.
Teacher, excuse me, teacher, what's the last one? What is it?
Cosec.
I'm saying it's negative what? The answer.
You have been negative cosec x code. Didn't you do that question? Thought you did it. Negative cosec codes. So let's look at questions. If share the following. Part 1, y equals sin 2x. I'm going to be brief, and now I've spent a lot of time on the previous work. That's not me. Now, we are differentiating this. Do you remember chain rule? Do you know chain rule? Chain.
Yes. Yes, teacher.
Okay, now we are going to apply chain rule. Remember chain rule? That's okay. Now for this question, part 1, y equals sin of 2x. We shall let our calculate maybe your U or your T to get 2x, meaning dt dx, you give here 2. Mean your y becomes sine of t. Mean dy dt. When differentiate sine, what do you get? Huh?
Cos. Cos x.
Okay, now I'm calling the t, which you get cos of t, right? Which will be dy. Your dy dx by change becomes given by dy dt times dt dx, okay? Chain rule, meaning dy dx now will be your dy dt you got sine t, dt dx you got a 2, which becomes 2 sine t, which will be now 2. But what was your t? Was a 2x. So this is what you get. That's the ddx of sine 2x. Any question?
Teacher, I beg your pardon, I'm lost. Excuse me, teacher.
Yes.
I'm lost, I beg your pardon.
You know chain rule?
Yes, I know.
Good. We began from here. Now chain rule, I let this angle to basically vary any unknown you want. You can use t. You have used t, right? Instead of writing 2x, I got right now t. Okay? Let your t to be this angle. Are you following?
Yes.
And your angle is a 2x. Now differentiate t. The t yes you get it, right?
Mm.
Are you making 2? Eh? Then you come back here. Your y becomes now sine of t. You said your 2x is a t. Your y be now sine of t. Okay?
Yeah.
Now differentiate, get the y dt. In differentiate sign, you get cos. The work we have just done, okay?
Yeah.
So this what now you come and this is what we call a chain rule. This expansion of the chain rule. Do you agree?
Yes, I do.
Then you come and substitute back here. Your dy dt is a sine t. You see it? It's a cos t, sorry. Yeah, you're right. I made that error here. Your dy dt is a cos t, which is equal to cos of which is equal to dy is a cos t. It gets the 2, which is equal to cos t. But what is your t? 2x. Okay? Is it fine now?
Teacher, it's trying.
Okay, do for me this question. This is your number, you people. Y equals sec of x squared plus 2x. Do for me that question. If that. Now, before you go, you only the work we did, you only do the previous. If we say if the question comes differentiate from first principle, that's when you do the first work which you did. But the work which you are doing right now, don't differentiate from. Just do apply chain rule. That what I'm doing here. Just apply the chain rule and you work out the question. Agaba and Karen. Agaba and Karen. Are you using one phone?
Yes, teacher.
Are you using the same one phone?
Yes.
Eh?
Yes, yes, teacher.
Why? How can you use one phone? Data is what?
Data.
Even if you are doing a phone, but
Teacher,
yeah.
I'm stuck somewhere.
Where?
And that number we're working out, obviously said we find, okay, if my first step was t is equals to x squared plus 2x, I differentiate it to get dt out of dx. So I got 2x plus 2 as when I differentiated. So I was like, y is equals to sec t. Yeah. Then to find dy dt, and use our answers. And when you're differentiating sec, you get sec t tan t. So now when I'm multiplying, I'm not seeing anywhere forward.
You get sec t tan t, right? It's also the value of that.
Pardon, teacher. Pardon.
You have after this, you have back the value of t. That be a solution. This is what you are.
Teacher, we remain with 2x somewhere. We remain with an x in the equation.
Okay. Let's work out the question. Just mark your work. Have y given by x. Squared and let your t.
Is mute program.
The ui becomes sec of t. The y dt will be now sec t tan t. By chain of dy dx, dy dt, multiplied by dt dx. It becomes dy dx will be dy dt, which is x t. Which should be now press of tx squared, then tan t. That's what you get. It's the derivative dy dx.
So teacher, we stop there.
Yeah, that's why you end. You leave it there. You can't go beyond that point.
Please mute.
Okay, our last time, I'm going to give you work over 100 questions. I'm going to send you work back book 2. That's a book 2.
No.
That was book 1. Book 1.
Which one?
Who has book 2?
Teacher,
Yes.
teacher, in trig, we differentiate dy dt and get the same thing. And then it's the x dt, and then you get 2. But now for you're getting dt dx and you're getting 2. But it's supposed to be the reciprocal. Okay, that's what we do in trig. And I don't know why you're doing dt dx and then you get 2.
Dx dt.
Like when you differentiate, you're differentiating the x dt. That's when you get 2x plus 2. And then dt dx is the reciprocal of what you get. But you're getting dt dx, okay, from x squared plus 2x. If you differentiate this, it's supposed to be the x dt, like that's what we did in trig with Hajkauka. And you're making us do dt dx, getting 2x plus 2. It's supposed
Maren, there is a difference.
Maren, teacher.
Here we are.
You cross multiply. Maren, you cross multiply.
No, her question is, okay, like in Hajkauka's work, we always have x giving us t. We have x, then they give us a value of t. But here we are having t. T is giving us a value of x. So you differentiate t in terms of x, not the other way around. There's a difference.
Yeah, thank you, Shas. Let's try to you. As calculus, how you have x giving you t. May I have t giving you x? Okay. Our last question. Before you go for your math 2. Anyway, I'm going to check. We have y. Give y cot squared. Let's be for x. X cubed plus 5x plus 2x squared. We add a 4. That's our question we are differentiating now.
Aisha, please.
But before we do this question, first look at this number. Before we do this question, first look at this question. This is too big. Let's begin this question before you come for that. Let's first differentiate y given by maybe sine squared x, like this question. Now, if you have a power, this can be written as y given by sine x. You take the 2 out. Oh, you know that. Right? You take the 2 out. Eh? Do you know that?
Yes, we know.
Oh, now you let your t to be now sine. But this question, this sine of x. Now your dt dx will give you a cos of x. Meaning, now your y becomes t squared. The dy dt will give you 2t. There, by change dy dx, it's dy dt by dt dx. Your dy dx will be your dy dt is a 2t. Your dt dx is cos x, which becomes a 2 your t sin x, then cos of x, which is equivalent to sine of 2x. Your dy dx for that question. This number here. Here. So if you have a power, you take the power out, you let your t to be this inner bracket, okay? Then you differentiate. So now this question we shall do it after. So you can't do it now. Shall do it on Tuesday. We are meeting again on Tuesday, right? God willing.
Shall we have to go shopping?
So we also have to go to Chibuli.
Shopping.
Teacher,
we have a wedding to attend.
Which wedding? And make sure you attend. I'm going to rock on. I'm teaching up Thursday.
Obstructing.
I'm going to roll.
Teacher,
Like
teacher, please don't Thursday.
You're coming back here till July.
Are you sure?
Till
what?
July.
Good night.
We are going to be at school for 2 months only. Teacher. Why not December?
Is where the bone good? Excuse us. December.
Okay, I'm going to send you work on your group. Okay, on your platform. That's what I'm saying.
You guys stop talking and we see the board.
People who are talking and keep quiet. I'm saying, I'm going to send work on your group. The numbers from backhouse 2. Have you heard? Did you buy the book too?
No, we don't have time.
It's broke, teacher. Buy a phone and you have to.
You don't have time.
For us, stop up. We only have 1,000.
You don't have time to go and buy.
No, we don't have money.
You have not stopped for us.
Don't come to my class with that book too. I'm telling you, don't enter that class. You don't have backhouse.
Teacher, quarantine, corona affected all of us. So
we are having a money crisis at home.
There's no money crisis.
You have to buy that book.
Teacher, talk to parents. Talk to our parents.
I shall not give you work, you wait. The work to do.
Mr. Semakula.
You can look at it. I've not heard.
I'm saying I beg your pardon on that part of the why because the sign is the where does the cost go?
This is a factor formula. 2 sine x cos s given by sine 2x. That would have angles. You know that would have.
Teacher.
This is given by that.
Okay, thank you, teacher.
Oh, you're
Okay, thank you, teacher.
welcome, Amanda. I'll check it. I'll fill in the group. If okay, you can go for break and eat, and you come back at 11 for math. Okay.
Teacher, pardon, I know you are getting sine 2x.
Double angles. 2 sine x cos gives you sine 2. Check your trade book. Still work you did. Got double angle, double to have angles, right? You'll find it. Okay, we meet. Now gone.
I don't know. I said I look at them. Especially, behind the moon, where I get so given area. So my shit, the gold good thing, other side of my friend open one day. Oh, Jesus, my face, I got it 4 months ago. They went to do the statistics time to people. I was scared. So I was sleeping. I woke up like this way. I told them when you start drinking, everybody like drinking comes together. Because I drank with someone almost had something happen there. I didn't listen to dreaming. I didn't we were told, here's into the platform, we are this because the organizing for this party to prepare. When we're preparing for this kind of outfit, we come find out the kids say that I'm saying I did right good. I'm saying I did right good. I think like, we are seeing the things that happen. My cousin said, okay, now my cousin can do it. I said, no, it's good seeing everything be better. It's the same thing. But I did not think it was you know, you're joking, you're playing. At the same time, doesn't mean they want to be a Okay, guys, you are in the kitchen. It's not in the kitchen, but they don't see the kitchen. Yes. They're just people who are listed in there. Just understand. Okay, sometimes it's I woke up. Then I was here, something came in my head because someone was going I was just scared. I swear I'm not going to lie. I was so scared. I can just with my cousin. That's very fun. In the night. In the night, that's very fun. I woke up, I didn't know. I had a bad dream. I just someone was really there and someone was really and then I was thinking that I was feeling hey, it's like that. You said that was playing in the middle of the night. Oh, I'm because there's no person when I take it. Because it's a funny game. Someone was very I was scared. I was very they got me. I'm just kidding. Actually, so my department was my sitting room, but I just left him. I still got them. When I took my mom just break. Trying to pray, because that's me. So many people so many colors you have seen. I see many people when you get you can't remember the dream. Just pray. It was just very then the following Wednesday, because I told my aunt she was very so they want to fast. I told my dad was like, when we're trying to tell my mission, But it happened in school. Yes, I do. Just move. Just understanding that you can. It's easy if it's automatic, but not It's so hard to get because you're ready to then she was still very, very quite undermining that that's the problem. Nothing to that, absolutely nothing. Because I was there, my elder brother was there. When he decided to send my auntie to watch. So I think because my younger brother had already told another young kid, saying, hey, I think he said that students and men will be teaching, not to respect your own. That's it. So now it's kind of you're not driving a car to have fast food. So now I reflected, you are very slow. Because that's why I say you should learn to be very flexible. Because in case things happen, you have to just react to it. But for how flexible, and even though it can be very like, you but also be flexible. He's still young. Things you don't do something very fast until you are still afraid. What did you take to that? But now this woman is like, no, I have to take it back home. Yes, just bring that back. And I get to put my baby and take back and meet you. Which is like, no, I'm going to take it back home. I have to try. I'm not going to at least. It's okay, but you can't never do it. I thought it meant something else. I tell you, people want to enjoy I think they really feel like, when you feel and just like I can get and go and just say, no, it's your mistake. Never did was like, it's only good at but because you are coming from the beach, coming ask like you are expecting me at the beach, but you have over time. When she over time, she plays a little bit. But for accident, only then I'm just going to say what happened to the because it's just doing now, but she thinks that she does that in that time. If you're all I can do that can know how to break, but they're not on the wheel. Yeah, so they're not on the wheel. They like to do like this, they not to do like this. She is just getting fish, she's screaming, and she has fish that is your something. Yeah. Can you make this a we are telling you what to do. We are going to tell you say what? She didn't even touch anything. You know, she had time to do that. She had time to do that. She had time to do it. Because when I try is moving, the first thing when you're going to get to do an accident, they want to have to my breakfast. The first thing in your head is to pull your hand away. So just pull it up. It's so easy to push. Just pull it up. It's not such a big deal. Because it can't, if it's a handbrake, yeah, you can't. We are waiting. Sure, at this time. No, there's something.
This is something I finished one time. What time is this?
At 9. 9.
So that
We have like
this one is going to be only. This is the last lesson.
So where are you going?
Huh?
Where are you going?
Yeah. Yeah, why?
Because it's the last week. Next week we have lesson. Okay, make sure the angel also meet you up like the other night.
That's what I was wondering. You may come to
Hey. I pray how did they survive? How did they get out? Now, do not know. Who's going to get them? Nothing happened. We just get out. That's it. Right, no. I give that. Yay! This is the one. What? Because it's not money. Just became money. Just became money. Yeah. He came on to the medical. First, you didn't know the gen exam. Okay, you got a broken arm because he banged his arm on the dashboard. Yeah. So for him, we got out. The woman was just in the stairs. She froze. She froze like she doesn't believe in she's still alive. In her head, but you know when you just freeze, like the crush was stuck on the wheel like this. They had something like big hearts to look at. Wow, crush was just there. So then it was like, my hand is broken. Yeah, and I'm like, the way she goes to my head, so simply the children that she had so many I'm like, oh my God, it's okay. Because the mother wanted to do it. That's because her mistake, and just accept the mistake. Then she also went to mention this and people are saying okay, because we could get a conversation. So the marriage wrote dinner. You got dinner's face, who's the matter that day? That day in the like his anger, hold this hand. You say, what is that in my head? Because that was the first thing I saw. Then after in my head, I was scared. I said, what has happened? Then I went and told my dad, I told that there was a dinner because so he knew that what? There was an accident, that was crashed. He threw the thing, I said, he came on. He said, what has happened? Auntie, the bank that day. She went to look at the so we took the dinner and Judy remained. Judy was a part of the accident, but she remained. But then his hand looked back. Then Jenna looked into the body and looked at the broken hand. And the one was driving was lucky because she had a seatbelt, but she now has some chest pain. Because the seatbelt really gives them a seat. But the problem with Jenna, you remember to put the seatbelt in the process of folding them. Yeah, but if he had put the seatbelt, he would have had an accident. So he wouldn't be affecting them too much. But when he didn't put the seatbelt, that was a problem. But anyway, either way, the kids survived because the car so because if it had fallen like this, it's going to be they put Jonathan, he rushed, he said, he didn't even look at the class. Now you go back to the way you were saying about the strength. Like a coach, he was telling he was skeleton. He was just he was scared, but he was scared. There is moving in that because the issue of ground, he was scared. Then after we went on, he then told us some anti-law, some anti-hospital. That's not they do you read? They do the bambi. Oh, what in the way? I think the actually better than grass. When we're lying at the boat with a broken arm. But they like looking at two kids. You think you will have so much information? Okay, I need because if you don't know how many people right, then you just sleep. You are going to so you pick up the well, the only the back bit was a bit still. I want the game is out slightly. How do you forget it? How do you get out of the same? I don't through the back window. The back window don't piercing. How do you get out of that? First, that's true. How is that feeling of professing? And what's the other? Look at me and the things. It was a dream. One way to strong, my dad was denying the prayer and what your professor then when my mom, when I told my auntie, they see that people have been told because if you look at that, you won't be very good. No one can support it. And you know, the telephone is very moment. And I think the good very important. How is the drawing? The drawing is different. What's also it's different and married shape, and some married shape. No, that's big and little. How do you say that? Once we are Because that's very weak. Because when the other weak focuses, the devil has come to some of it. Because apparently wasn't even when different didn't have to pay. The next thing they then the other week on Wednesday, it's okay, and everyone's it's like my dad was scared. Because of the way I had nothing. Then my question is very yeah, good makes it good. But anyway, I was like, it's good because it has taught him something. It has taught him something because he's not a different person, but he knew it. But very good where because you know there are too many factors who lie. Especially when he was scared of the lie. So when he was like, I'm done with this. I'll just believe that he's there. But I don't want to believe people who say that he's there. Because we are all lying there. The next that you can't say that you believe in something like that. But he knew that. Then my answer was like, you are Walk with him, talk to him, love her, love her. What's her name? Jesus. Yeah. Amazing grace, amazing love. It's the Lord's Prayer. The example of the Lord's Prayer. Done. What? Hey, it's a job. What's that? No, that go for you. This one. Replace that. Yeah, we'll place it again. That's the thing. Leave it somewhere. Yeah, so which one? No, it's not like this one. Sorry, let's do that. Kasi ito siya ko man may say. Children of light. What's that one? Hello. No longer slaves. No, the children of light. This is 1 hour. Eh? No, not that one. Eh? That is somebody. Yes. 1 hour. Yeah, that's it. The longer slaves. They have a. Oh, yeah, that is. No longer slaves. That's a woman. That's a woman. Ini sana. No. That one. What's everything? All that's not expo all that. Yeah, exactly. Which are so. I like what Samsung got done by this first. John is can you do in your own I'll put you in front of my memory. You are all that matters. You are all that matters. I'll make room for two. My you are all. You are all. No, I'm not going to send. I'm not going to. Is it your son? You are what the is. They have good voices. Somebody can make so that I can understand the words.
Before is teacher.
Teacher is coming.
Which teacher, by the way?
Mr. Lubega.
But on the TT it's saying teacher Mulun.
Yeah, the timetable is saying Mr. Lubega, but we have a Mr. Lubega. Yeah.
Okay.
Who is that I'm talking to?
Is it Mavita, right?
What?
Mavita.
Oh,
Mavita.
Mavita. Mavita, what's
It's
that?
not Mavita.
Hey, mobile.
It's not Mavita.
Who?
I'm Lillian, but I thought that maybe it's your Mavita.
Ah, yeah, wait, Mavita.
Who are you then?
I don't know, like, I'm Lillian. Yeah, Lillian.
Now tell me your name.
Adoyo.
I Adoyo, you can fool you, girl. You. I thought that maybe I was speaking to someone who sensible. Adoyo. Yes. Yes, Adoyo. You're not a simple human being.
I don't want to make that. Why are you taking this beer? Can you be nice?
Who is that one?
My
His music.
My best is here. Have a good time.
Good time with who?
Eh?
With who?
Jill.
I see. Have.
Maybe people are taking tea for your chili, yeah?
What is it?
Well, you by chai.
Are you done with holiday work?
God, I don't know that. I want to
Lucy.
You guys don't need your videos. I can call you one
now. Adoyo, what are you doing at school?
Who told you about school? Can you unmute? Lucy, love issues to sort out.
We are going to get.
Unmute your video. What you? Some of it
in the school.
Don't ask me those questions.
Are you we are going to be there. So, but teacher Lubega is on phone. You are teacher. Adoyo, you have many questions to answer. Why are you at school? For sure, this was too unfair.
Come to me and
Yes?
you want to know. You're dying to know.
Good morning to you.
You will explain.
Good morning.
Good morning, Mr. Lubega.
You're fine? Are you fine?
Yes, teacher, we are fine.
Okay.
Yes.
This is my last lesson with you. Other lessons will be taken up by Mr. Mlondo and Mr. Twaha. I have to go somewhere. But it's okay. When I report, isn't it 23rd? 23rd. You're reporting 23rd. And
I know that some teachers had refused to perform, so you will adjust it.
Okay, I don't know. They will inform you in case of any changes. In case of any changes.
I've already worked that is not getting that.
Yes, nice. Like, yeah, like. No, he told you connected.
Lamis theorem.
Lamis theorem. Equilibrium of forces. You will do that in a time. So, yeah. Yeah. So you write the question, and are they listening? They write what they want me to write. Can you imagine? Forces of magnitude. Forces of magnitude of 6 newtons, 5 newtons, 3 newtons, 2 newtons, and 1 newton acts along sides of a regular hexagon. Up along sides of a regular hexagon. A, B, C, D, E, F of sides 2 meters. First I want you to come and sit here and work from here. Alongside work from here as you see the teacher. For you, your work, I want you to hold me. Alongside the heavy comma.
People teacher has disappeared.
No, please. I've not yet disappeared. I've not disappeared.
Yes. Hey, Mr. Namdala.
Yeah, we are working on something. Don't fear. Wanji? Kati ky'oba okola gwe fulumamu ogende mu Zoom oyingiremu okozese account. Now one at gmail.com, password small p, and just capital letters 2021. Just fuluma ogende mu Zoom oyingiremu okulinda za account za. Na bisunsa small letters na bisunsa 1 na bisunsa 1. I want you to be open. You need to have the hope that you need a math guys. You just come and talk to the don't touch you. These people who come online, you just tap on their names. You come and tap here, like she's doing which subject. If I never fridge, you could say this year math, this one this year math, this one this year math, this one this year math. You just select a sign, send them to math. And this one I don't know about which subject. Like math. Trace math. Trace math. This one math. For you, that's what you do. Whenever, how do you know that someone has come? You look at here, breakout room, it will be having numbers of people who are unassigned. So for you, just come and you tap. You see? Yeah. That's how you help me. That's how you get a little job. You see? Maybe we are starting even this. For you, always your place, go there and look at how many are unassigned. If I don't know that someone is doing French, you just tap on hand name, you tap on break up, you assign the person.
That is for today only.
Are making noise on my phone to start.
So part A, the point. The point where
She's calling me. So that you can be seen.
Where is the line of action?
You tap on the other side where it assigned to. You have done it.
Where is the line of action of the result and start FB? Hope you guys are copying the question. Someone is saying I'm lost. Why?
Just question you lost.
Oh, no, I'm not. I'm now found. So this is a beautiful question. I can give it to Mr. Namdala to do it for us. He's still around. They want you to find the magnitude and resultant of the directional joint force, and this is what we are supposed to last time. Good issues. So they want you to find a point where the line of action of the resultant cuts AB. The point where the line of action cuts AB, line of action of resultant cuts AB. Line of action of resultant force cuts the side AB. So this is the hexagon, and you know hexagon is six-sided. We call it regular because one side is equal to 2 meters. We have 2 meters here. It's a regular hexagon. So we draw the graph, sorry, the diagram. I want to grab off these up somewhere. Are you done copying the question? Are you done?
No, teacher.
Please copy the question down and we continue.
Yes, for you, teacher. Actually, I've said COVID. What? COVID is increasing.
So chances of lockdown, second lockdown.
Let them leave us.
I can't sit down.
Oh, no, these are.
Are they examiners?
No,
These are for. I don't know.
These are checkers.
Those are checkers.
That's fine. We can't be an example. That's stress. By this time. Sure.
Teacher, we have a lot of work to do. But still bring the work and your stuff. It's not.
I think the background also coming back to issue. I'll start with the equilibrium of forces.
He said they will read through the paper.
Very nice. The people are waiting.
Okay. Are you done copying question? Yeah.
Yes. Yes, teacher.
Oh, please hurry. Hurry before it starts raining. You know what happened last time?
There is no sign of rain.
Really? Where?
So you mean it wants to rain?
What's the content?
No, first we have signs. It's almost.
Teacher, we are done. You teach.
Teacher, we're done.
Done. People are done. But done. So we sketch the diagram. Sketch the diagram. We can start with a rectangle and start with a rectangle. Then we split it into two. Please don't use freehand. Draw the first diagram. Huh? Don't use freehand. Now, before you continue, what is most important is this. Cut inside AB. Make sure I make this side AB the horizontal so that you can know where the line cuts it. So they said AB. If it is BC, you put it here. If BEF, put it there. So ABCD then E and F. AB, they said A to B, the order was A to B, 6 newtons. They mentioned the B to C, 5 newtons. They mentioned the D to E. Order is important. D to E, 4 newtons. Then they mentioned the A to F. A to F, 3 newtons. They mentioned the A to D. They mentioned the A to D. A to D is 2 newtons. And then they mentioned the SC, A to C as 1 newton. I think this time you can see the diagonal forces. For 6 newtons and 4 newtons, it's just direct because they are acting horizontally. But all the other forces, 5, 1, 2, and 3, are acting diagonally. Meaning we need the angles they make with horizontal or vertical to resolve them. So looking for the exterior angle, but not using freehand. That dotted line, don't use freehand to show a dotted line. So we have an acute angle there of 60 degrees. I'll use 60 degrees to resolve the 5. I have 3 Newton's force this side. I add a dotted line, but using a ruler. The acute angle, exterior angle of hexagon, I told you the exterior angle is 360 over number of sides. 360 over 6, there are 6 sides, so each is 60. So the interior angle is 120. Now, I'm interested in 2 Newton's force, and you know lines FE, AD, and BC are parallel. So the lines are parallel, meaning the angles they make with the horizontals are the same. 60 degrees here, 60 degrees there, and 60 there. So I'll use 60 degrees to resolve 2 newtons. Then we have the 1 Newton's force. The 1 Newton's force is formed by this type of triangle. It is A, B, and C. It is acting along this diagonal SC. But remember, this is a regular hexagon, meaning that all sides are equal. All the 60 sides are equal length. So if this side is 2 meters and this is 2 meters, that means, okay, this is the angle at B is interior, 120. So from 180, 120, 60, the base angles are equal. So by 2, the base angle will be 30 degrees. This is 30, this is 30 degrees. So the base angles are equal. This is 120. So the base angles are equal to 30 degrees. Meaning, I use 30 degrees to resolve the 1 Newton force. So all the forces are now theta 4. So we determine the resultant by resolving 1 by 1. So this is R is equal to, the first force here is 6, X is 6, Y is 0. I move to the 5 Newton's force and using this exterior angle of 60 here. So it will be 5 cosine 60 degrees and 5 sine of 60 degrees. Because the force is getting up from point B. Yeah. If it is coming, then the components will be negatives. Plus, I'm rotating outside. This is, we move to this force, X is negative and has no Y. Plus, we move to the 3 Newton's force here. it is coming out of point A, and so should the components, the horizontal components here and the vertical component there. So X is negative, but Y positive. So you get one sign wrong, everything goes. Supposed to put combination. You people, you put the combinations. Who is Nampijam? Your combination? Plus. So this is going to be negative 3 cos 60 degrees, positive 3 sine 60 degrees. Plus. Then we go inside here. I'll start with 2 Newton's force. The 2 Newton's force makes 60 degrees with the horizontal. So it is going to be 2 cos of 60 degrees and 2 sine 60 degrees. Plus, I go to the 1 Newton's force and which makes 30 degrees with the horizontal. So it's going to be 1 cos 30 degrees and 1 sine 30 degrees. So 1, 2, 3, 4, 5, 6. Those are the 6 forces. They want us to get the resultant. Resultant. What is the resultant vector? Resultant vector, the horizontal component. Horizontal component. So what do we get? 4.8660. Then down. Has entered. He entered.
9.5263. 9.5263. 9.5263.
63. Again. Please confirm the vertical component. Confirm the vertical component is fine. Confirm.
For me, I've got 9.1603.
9.1.
9.1603.
Okay. Newtons, thank you. But please don't underline that. That's not the answer. We get the magnitude of the resultant and direction. 4.660 plus 603 squared newtons. And then, so we get the direction. Both are positive. So the horizontal component is positive, but don't use freehand.
Excuse me, teacher.
Yes.
He said when I just entered.
I'm so sorry to take you back, but I've been having network issues the whole day. So I ended when we were just getting the resultant. Could you please summarize for me, please?
Dream. Dream, let come. Really? Taking me back? Where? Right here.
Right, yeah, when we were just getting the resultant. Edwin, where are you, Edwin? We don't know
Edwin,
where
where are you? Yes, teacher, there.
Where? Here?
At the beginning.
The diagram.
No, I left on your drawing the diagram. Now finding the resultant.
Okay, but then did you draw? I mean, do you have this question?
Yes, I have the question.
Okay, that is fine. So this is the hexagon A, B, C, D, E, A. So the forces have been given. They gave 6 newtons along AB. Now to resolve the 6 newtons along AB, AB is horizontal. AB is horizontal, which means it has and to the positive direction. That's why it is 6 is 0. 6 is 0. 6 is 0. Plus, we have the 5 newtons force, which is acting along BC and making an exterior angle 60 degrees to the horizontal. So to resolve the 5 newtons force, we use this angle, it makes with the horizontal 60 degrees. So it will be 5 cos 60 degrees, then 5 sine 60 degrees. They are both positives because the force is moving out of point B. The components are facing the positive directions. 5 cos 60, 5 sine 60. Plus, rotating, we move to this 4 newtons force, which is acting horizontally. And to the negative, that's why it is negative 40. Negative 40. Then we continue no force along EF. We have a force along AF, not FA, but AF. So along AF, it is making 60 degrees with the horizontal, that exterior angle here. So resolving the exterior angle, I mean using exterior angle 60 degrees, we have the forces moving out of A, and so should the components. X is negative and Y upwards is positive. And this component is adjacent to 60, that's why it goes with cos. So we have negative 3 cos 60, this, and Y is positive 3 sine 60 degrees. Yeah, that is 3. So we are left with these 2 forces inside. We have the 2 newtons force and 1 newton force. So the 2 newtons force, the angle, the diagonal ED makes with the horizontal is 60 degrees. And we said, because the diagonal AD is parallel to diagonal FE and parallel to diagonal BC. So all these, the 3 lines are parallel. So the angles they make with horizontals are corresponding. So this is 60, 60, even this here, 60 degrees. They are all corresponding angles. So using 60, we get positive, positive. 2 cos 60, 2 sine 60. And finally, we have the 1 newton's force. But the 1 newton's force is in the triangle A, B, C. But remember, I told you this is a regular hexagon, meaning all the 6 sides are equal length. So AB is equal to BC, meaning triangle ABC is isosceles. And starting with angles on a straight line being supplementary. If this is 60, the balance would be 120 degrees. So from the isosceles triangle, base angles are equal. So this is a base angle, a base angle. So from 180 minus 120, that is 60 by 2, we get 30, 30. So we use 30 degrees to resolve the 1 Newton's force. And that's how we have come up with 1 cos 30 degrees, 1 sine 30 degrees. So you don't need to simplify this, just put on your calculators and get this. So we have this, but remember, we have to give the resultant in terms of magnitude and direction. So you get its magnitude, 1 newtons. Then we want to find the direction. We want to find the direction. So this component here.
Thank you, teacher.
Welcome. And then the vertical component is positive. So this is 4.86060. This is 9.1603 newtons. So the arrows suggest one possible movement. This here. If I use a solid line, then I put 2 arrows to distinguish it from its components. And then the resultant is acting at an angle theta to the horizontal. And actually that's its direction. So theta is the arctan opposite over adjacent. So this will give us theta as the direction.
Teacher, how come in the resultant it was 4.8660 and then here it's 4.86060?
Okay, sorry, this is 660. Oh, no. There is 1 6. Yeah. 62. So we get 62.02 degrees. So you say to the horizontal. To the horizontal, someone can say to FB, because FB is also horizontal. Or someone can say to ED, because ED is horizontal. To the horizontal. As simple as that. Those who want to use bearings, you are free to do that. You can say east, that angle north. You can say the direction is east, that angle north. Who is this one? Unassigned participant.
Which area, please?
Are they the ones you're looking for? That one assigned. So that's it. Are you done copying this? We want to look at the last part, getting where the line of action cuts FB. Getting where the line of action cuts FB.
Cannot yet.
Oh, please hurry, because we have to finish this today. Today.
Her name is Mashe.
You forgot us.
You forgot us from Precious PCM Research of everyone.
I think they're just jazzing. They're friends. Karen, I'm sending you to your class. You're not going. What's the issue? Don't you do math? And praise what subject? Art.
Math.
I think they do. And this is that. Stop, man. Yes.
Okay. Done. Want to continue?
Teacher.
Done? Said yes. Huh?
Yes.
Okay.
Yes.
Okay. Part B.
Teacher, Manyiki, one breakout room has disappeared.
One room.
What happened? Hey, it's there. That's some girl.
Part B.
Please wait to remove the diagram.
Should I remove the diagram?
No, first wait.
No, actually, I can't remove the diagram because we are going to use it to put the components.
Yes.
But at the same time,
we are going to use that diagram to add the components. And that's where I need people to pay more attention because they might get lost. Let me use the example, the way it was taught you lessons. To find where the line of action cuts AB, we use the equation of line of action, but the point where moments are taken should be the origin. So taking moments about point A, the sum of moments G is equal to XY, then sum of forces horizontally and the sum of vertical forces. So what do we need? Sum of forces horizontally is 4.8 and so on. The sum of forces vertically is 9.1603. So what we need basically is the G, only the sum of moments. So we take moments about point A because that's where we want to measure, isn't it? Now, in case you get a distance which is positive, you move that sign to the positive direction of the x-axis. In case you get a distance which is negative, then you take the opposite side to the origin. So the sum of moments about AG equals. So we have survived all these forces whose lines of action are passing through point A, such as 6 newtons has no moment because it has 0 perpendicular distance from A. 1 newton, no moment. 2 newtons, no moment. And 3 newtons, no moment. Meaning, we are only left out with 5 newtons force and 4 newtons force. Now, when you look at the 4 newtons force, its perpendicular distance is direct. You can directly see it. It's just direct. The perpendicular distance to 4 newtons force is the length AE. Is the length AE. So because you see this is 90 degrees here. So that means we have to calculate length AE. How? Using the dimension of the sides given us as 2 meters. So to get length AE, I'll use length of this side, which is 2 meters, and this side, which is also 2 meters. I have 2 meters. This is 90 also. Length AE is made up of this distance y, for instance, which is the same distance y here. So length AE is equal to 2y. I'll find 1y and times it by 2. I need length AE. Length AE equals 2y. But to get y here, I'll use the right angled triangle at F and E, and then y from the center here. Remember, this is 2 meters, and half of the interior angle 120 is 60. 60 degrees. Someone wants to use the angle AED. This one. Good one.
Matthias, what do you do?
We don't have, we want to use this angle. What is this angle? Because
I'm not.
This is 2 meters.
I
Unless
think
you get
it's
this.
that.
If it is 30, then that is short. Okay, so we want to find length AE, which is 2y, y plus y, y plus y. But let us get only the length of this side and then times it by 2. Using the triangle along AE, FE to this point, and then that side, 60 degrees here. So the distance is opposite to 60, meaning I'll use sine 60 degrees. Sine of 60 degrees equals to opposite over hypotenuse. This will give us y as 2 sine 60 degrees. And this will give us root 3, or 1.7321. Root 3 or 1.7321. It's okay, you can have this to 4 dps if you want. 1.7321. Now, after getting y, that means the length AE, which is the perpendicular distance to ED, to the 4 Newton's force, AE, we multiply this by 2, which will be 2 root what? 2 root 3. So this force here is catered for now. I'm left with 5 Newtons. The moment for the 5 Newtons force. Now, when you look at 5 Newtons force, we don't have the perpendicular distance from A onto the force. And the moment you lack perpendicular distance, then you resort to the components, because components are acting horizontally and vertically, i.e., the horizontal component to 5 is this here, which I may not even include, because its line of action is passing through A, and it will have no moment. Then it is acting along line AB, so no perpendicular distance. 5 cos 60, and then the vertical component, which is 5 sine what? Sine 60. Instead of using 5, we can use the 2 components. Horizontal component, no moment. Vertical component is this, whose perpendicular distance is length AB. The perpendicular distance to this component is AB. And AB is known to be 2 meters. So the sum of moments is going to be, I'll start with this, 5 sine 60. Now, this is, this force here rotates anti-clockwise about A. It rotates anti-clockwise. and therefore a positive.
Starting with 5 sine 60.
Teacher, please erase the board.
Really squeezing your
Teacher,
work
why
and
are you
now we're
starting with
getting
5 sine?
confused.
Hey. Do what?
Teacher, just re-echo everything. We're confused.
Teacher, repeat, we are confused and
Teacher,
lost.
can you please repeat? Teacher, please repeat.
Is compact. I know people are lost. Let's see if I just lost.
Very.
We want to get the sum of moments. For the 4 Newton is force, we need length. The perpendicular distance will be length AE. Will be length what? AE. And how do we get AE? We shall get this AE is equal to 2y. Length AE is equal to 2y. That is the perpendicular distance to the 4 Newton is what? Force. And then to get a length AE, you can use cosine rule with 120 degrees here. Because you have 2 and 2 meters here. You can use cosine rule, and we don't use forces. We use the dimensions, the 2 meters, the 2 meters, to find length AE. Or you can get distance y, which is half of it, and then multiply it by 2. How? We extract the right angled triangle. This is F, this is E, and 2 meters, then 60 degrees here. And this is length y, half of AE. This is opposite hypotenuse. Therefore, sine of 60. Yes? Sine of 60.
So where are we finding
Pardon?
Where are we finding this thing? Because I thought that the 3 Newton force passes through the S, so it's going to.
No.
So it doesn't have.
3 Newton is there. This diagram has forces which don't have even moments, such as 3 Newton is force. 3 Newton is force has no moment because it is passing through A. 2 Newton is force, no moment because it is passing through A.
Yes.
1 Newton, no moment because it is passing through A. 6 Newton is no moment because it is passing through A. So we are left with this and this, only those two forces. We want to get the moment of 4 Newton is force and the moment of the 5 Newton is what? Force. Now, for the 4 Newton is force, the moment from A is anti-clockwise and its perpendicular distance from the turning point A, where you take moments from, is length AE. That's why we are finding AE, because it is the perpendicular distance. It is the perpendicular distance to 4 Newton is force. That's why we are getting length AE. Is that okay? We are getting length AE because it is the perpendicular distance to the 4 Newton is what? Force. And to get AE, remember this diagram is symmetrical about line FC. So if I can get halfway, then I'll multiply by 2 to get length AE. So we need length AE. Have you seen that? We need
yes.
length AE.
What's the lesson you're going for?
So sine 60 degrees is opposite over hypotenuse. The hypotenuse is 2. This will give us y as 2 sine of 60 degrees, which is 1 point. If you want to give it as a decimal, then it should be to a minimum of 4 dps. Or you can use the special angles. Y is 2 sine 60, but sine 60 is √3/2. Or you can give it as a decimal. This is root 3. If you want, you take 1.7321. That is y. But we know AE is 2y. So 2 times y, we get 2 root 3 meters. Without distance AE, you can't find the moment of this force. Now, having got the moment of this force, we identify how it goes. It can be it can be clockwise or anti-clockwise. If it is rotating like this, clockwise. Rotating like this, the way it is now, anti-clockwise. So its moment is positive. That means we can now get the moment of this, but before that, let us check if we have the perpendicular distance to the 5 Newton's force here. 5 Newton's force, this. We don't have the perpendicular distance. So we use its components. We have a vertical component here of 5 sine 60 degrees and a horizontal component of 5 cos 60 degrees. But 5 cos 60 degrees as a component is going through point A. Is going through point A and therefore has no moment. It has no moment. So I'm left with only the vertical component. I'm left with only the vertical component, which is also anti-clockwise because it is facing upwards, anti-clockwise about A. And the perpendicular distance to this component is the length AB. AB is 90 degrees, right angles with the component. So AB is the perpendicular distance. Therefore, taking moments about A, the sum of moments G will be, I can start with 4 positive. It's a positive anti-clockwise moment, they're positive. The force is 4 and the perpendicular distance is AE, 2 root 3. Plus the moment of this component of force, which is 5. Are people seeing? Okay, 5 sine 60 degrees times the perpendicular distance, which is AB. The perpendicular distance is AB. AB, which is 2 what? 2 meters. I don't know if people want us to first see. This is force, the perpendicular distance is AE. Plus, this is anti-clockwise, 5 sine 60 degrees times the perpendicular distance, which is AB. But this will cause confusion because you might forget the signs of the moments. At times they are negatives and at times positive. So this is 4 times 2 root 3 plus 5 sine 60 degrees times 2. What do we get? This time we are getting positives. We are getting positives, but you can also end up with negatives. You should be careful with the type of moment you have, whether clockwise and clockwise. Stay easy. 20? 6? 2 meters. Sorry, that is Newton meters. The sum of moments. Now, since they did not request for the sum of moments, then it is not a must for you to put the units. So we are going to substitute into our equation. This one, this equation here. So the sum of moments is 22.5167, which is equal to xy. The sum of x, what is the sum of x? What did we get as the resultant? Sum of x1.
Teacher?
Yes?
Teacher, question before you continue. Teacher, what if we had a force along CD? How would we find its moments? How would we write them?
Hello?
If we had a force along CD, how would we find its moments?
I'm going to show you that in the next example. What is the time? Yeah.
Okay.
The next example. The next example. The next example.
Yes, teacher.
What was the sum of forces here?
4.860.
4.860. And then
9.1603.
So this is 22 point, and make sure you write the correct thing here. So don't write first matrix. So this is 9.603x minus, we get the determinant, 0y. That is the equation of line of action. Then we use it to find FB. Sorry, we use it to find where the resultant cuts line FB, i.e. the x-axis. Any line cuts the x-axis when y is 0. When y is 0. When y is 0. Michelle. When y is 0. So we say line cuts FB, but FB is same as x-axis. When y is 0. Line cuts x-axis when y is 0. So when you put y is 0, we shall be left with this. You divide and get x, but no, that's not the final answer. So I want to erase this. Hope you have written.
Teacher, how does the remind what she does? She's the only one who is still. I've seen her like 10 times. She's coming back.
Nabimanya, by the time she comes back. Network or she does more.
I said that math, leaves, everything. She's coming back here. I don't know.
As an assignment.
Yeah.
You can record that. Nabimanya,
Teacher.
What's your combination?
Teacher.
What's your combination?
Men.
Okay. Okay. Someone is asking a question.
Teacher, please re-explain why you equate y to 0.
Okay, those are intercepts. Those are intercepts. You know where the line meets the x-axis and where it meets the y-axis. If you have these as your axis, the x-axis and the y-axis, this is the origin. Any line cuts the x-axis when, okay. So if this is point P, you see from the origin you move x units and you don't move y. If this is point Q, x we don't move and we displace a vertical distance y. Therefore, any straight line cuts the x-axis when y is 0. Any straight line cuts the y-axis when x is 0. But now our FB is along the horizontal axis. The origin is acting as point A, and maybe we have point B along this axis. So any line cuts FB. You go and doze from, no, don't stop dozing.
I'm awake.
Go and doze from, why do you keep Okay, so that's why the line cuts the x what? Axis. What are you doing here? Why don't you go there? Okay, so we put 0. That will give us 22.51679160 minus 0. When you put here, you get 0.
Excuse me, teacher.
What do you get as x? Yes?
2.4581.
2.4581. But that's not the answer. And by the way, from the origin A, do you see that this point is beyond the 2 meters? Because we know AB is 2. So when you get point something, that's already beyond B. So in your conclusion, you have to mention produced. If the word produced is not there, then you don't have the final one, the final marks. So you say, the resultant cuts AB at 2.4581 meters, because they gave the units as meters, from A along AB produced, meaning it's after point B. But if you get a distance which is less than 2, such as 1.8, then you don't need to mention AB produced. Just say it cuts it at that 1.8 from A along AB, and that's enough. But here you have to mention AB produced because it is beyond. If it is negative, this side you say BA produced. Yeah. If you get a negative answer, but you should be careful with the signs, please. Be careful with the signs for the moments, whether clockwise or anti-clockwise.
Teacher, I can't see a video.
Excuse me, teacher. Excuse me, teacher. What of when we have a rectangle? Which angle do we use?
Rectangle.
Yes, which angle?
The rectangle. Rectangle. The diagonal force to resolve diagonal forces. To resolve diagonal forces for rectangle, you use the dimension.
Yes.
Huh?
Yes.
To resolve, if you have a rectangle, you use the dimensions to get the diagonal angles. Yeah. Arafat Malende, that is teacher.
No, teacher is marking. I think someone has signed in using Arafat.
Excuse me, teacher.
Are you sure?
Yes.
He's around. Okay, who signed in as Arafat Malende? What combination do you offer? What combination do you do? So I want to give another example before it's late.
I've just put as a math. You have put the person to math. Some minutes for writing.
Excuse me, teacher.
Yes.
Teacher, the board is unclear. It's quite blurry.
Really?
Yes.
Yes.
Like we can't see what we're writing.
See you. Oh, what you're writing.
Sorry. Is it network issues? What is it? That side? Yeah. other bodies. So, sorry, I think we need to do.
Senior Begomazi, Bako Pagun. But I screenshot, whoever in a study China.
Okay.
Yeah, she said now it's okay.
It's okay.
Not done? Huh? Are they done?
Wakasi. When you got blessing. Yeah? When you got blessing.
So,
excuse me, teacher.
Yes, please.
Just for clarification, you said that when we don't have the perpendicular distance, we use the components. And for this case, we had 5 sine 60. And we are using it, we are going to use it to pass through distance of AB. Now, my question is, why are we using 5 sine 60?
No, because you see that the 5 newtons that I've circled here, these 5 newtons have no perpendicular distance. They don't have a perpendicular distance. That's why we use its 2 components. The first component horizontally is 5 cos 60 degrees, but its line of action is passing through A. That's why it is not considered. It has a 0 moment. Then the other component is 5 sine 60. Which is acting vertically. And by the way, the reason as why we use components, because they are horizontal and vertical. you can't fail locating their perpendicular distances. So the 5 sine 60 will act as just like my ruler here. When they ask you to find the perpendicular distance from point A to the ruler, you can see it is the distance AB. If this is my ruler, don't you see the perpendicular distance is at B? The perpendicular distance is at B.
Yes, teacher, thank you. I've understood.
Okay, welcome. So maybe people want to look at what we do to take moments. I think we need to work on this. That's why you guys are not seeing. So you can write the example and we see how to get moments. Someone is asking about, so you can write forces of magnitude, question. Marine. Forces of magnitude, 10 newtons, 8 newtons, 6 newtons, 4 newtons, 2 newtons, 3 newtons, 1 newton. Let this be and 1 newton. Act alongside the BA, BC, CD, DE, FE, and the FC respectively, of a regular hexagon, of side 2 centimeters this time, of a regular hexagon of side 2 centimeters, of side 2 centimeters, full stop. Full stop. The direction of forces indicated by the order of letters. The direction of forces indicated by the order of letters. The direction of forces indicated by the order of letters. Full stop. Determine part A. Determine part A. The magnitude and the magnitude of the resultant force. 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 And the inclination and the inclination of the resultant and the inclination of the resultant to side BC, and the inclination of the resultant to side BC, and the inclination of the resultant to side BC, the inclination of the resultant to side BC. Yes? I said,
what's after on the board? What's after you've written on the board?
I said determine the part A result magnitude of the resultant, magnitude of the resultant, and its inclination to side BC, and then part B.
Teacher, you've missed the direction of forces indicated by letters.
Oh, I told you, try it, sorry. From here, the direction of forces are indicated by the order of letters. The direction of forces are indicated by the order of letters. Even if that is not mentioned, okay, the direction of forces are indicated by the order of letters. And if that is not mentioned, you have to put the forces based on the order of letters. Find the magnitude, thank you. Find the magnitude of the resultant and its inclination to say BC, and then part B, the point where the line of action, the point where the line of action of the resultant cuts side BC, cuts side BC, cuts side BC, cuts side BC. So this is BA, BC, CD, DE, FE, FC, and the FA, and the FA, and the FA, and the FA. BA, BC, CD, DE, FE, FC, and the FA respectively, and FA respectively. So those who have not understood, please, how we get moments. The first part, you know, you can do that. I'm interested in this part, the last part. Have you written a lot of letters?
Yes.
So we can do that quickly. And in that question, please, they have mentioned where the line of action cuts BC. So we better make this the horizontal. We better make it the horizontal. So this is what we have. Better make it the horizontal. Better make it the horizontal. Better make it the horizontal. So this is BC. Better make that side the horizontal. This is BC, therefore it should be, remember we must have continuity. A, B, C, D, E, F. They said B to A, 10 newtons. Then B to C, 8 newtons. Then C to D, 6 newtons, and then D to E 4, and then FE 2 newtons. Huh? FC is 3 newtons, and then huh?
That's all you give us, but there's another
FA, we added FA, 1 newton. So this is what we have. To resolve 10 newtons, you need the 60 degrees. To resolve 6 newtons, you need the 60 degrees. To resolve the 4 newtons, you need the 60 degrees here, half of 120 or this. To resolve the 1 Newton is force, you need 60 degrees here, or this one. To resolve 3 Newton is force, the lines AB, FC, and ED are parallel. So if this angle is 60, this angle here is 60 and 60. Angles made with horizontal. So this will give us, that means you can resolve. You get the resultant quickly, that is 80 plus, that is 6 cosine 60 degrees, 6 is sine of 60 degrees, plus, this is -4 cos 60, positive 4 sine 60, then plus, this is 20, plus, you resolve this, -1 cos 60 degrees, -1 sine 60 degrees, plus, move to this, -10 cos 60 degrees, +10 sine of 60 degrees. And lastly, there is this one here, the 3 Newton is force. You can resolve using point C or using this. So it is coming towards the C, X is positive, Y is negative. 3 cos of 60 degrees, -3 sine of 60 degrees. What do we get? I just wanted us to get the components. So the resultant will be a, yeah, it's okay. So we get 7, and then this is 11, 8, 8.5, 10. We got 7. This is 11. 11. This is 8. This is 7. This is 9. This is -1. 1.5, 3.5, 2.5.
Someone put your answer in the chat.
For Y is 13.8564. 13.8564.
Thank you. Then X is?
7.
Really? Have you confirmed? Have you confirmed 7? This is 10. This is 5. 5. It is?
yes.
I can't see. 7. Yeah, 7 newtons, but you can continue. Get the resultant here, newtons. Get the direction. Get the direction. I know you can do that. I'm interested in part B. I'm interested in part B. So for part B, we are going to use the equation of line of action, taking moments about B, because that is where we are taking moments about. The sum of moments G is equal to xy, sum x is sum y. So the sum of moments G will be the sum of moments, okay. So this is the sum of moments G is xy, sum of horizontal forces is 7, here 13, 8, 5, 6, 4. We are waiting for the sum of moments only. So G is going to be 8 has no moment, 10 has no moment. So this time we are left with the 6, 4, 2, and 1. You can check UNEP 2000. They wanted moments of these forces rotating. So to resolve the 6 Newton's force, I mean to get the moment of 6 Newtons, we use its components. The first component will be this vertical one here, and then the horizontal has no moment. So we have only this. We have this, which is 6 cos. It will be 6 cos of 6 sine 60 degrees. And it is anti-clockwise, therefore positive. So I'll say positive 6 sine 60 degrees times the perpendicular distance, which is BC. And they gave to us 2 units. Plus, the 6 is done. This horizontal component has no moment. So we move to the 4 Newton's force. The 4 Newton's force. Now, there's someone was asking about this force here. We can resolve it using, we can create a vertical here, but that is taking a lot of time. The best thing here is to resolve the forces to take components along this inner rectangle. You better take components along the inner rectangle. How? Using this point here. You know this is exterior angle 60. So when you resolve 4, the horizontal component is this here, and the vertical component is this, towards the point E. So this will be 4 cos 60 degrees, and this will be 4 sine 60 degrees. You better resolve using this rectangle, the inner one, so that you have the perpendicular distance BC, than someone who will resolve using this angle, because you have this component and this. Now the perpendicular distance to the outer one will require us to look for this distance. So we better use the inner part so that we don't look for the distance. We have the distance already as BC. So we have these 2 components, and they are anti-clockwise. Meaning this component has a perpendicular distance of BC, and it is anti-clockwise. It is 4 sine 60 degrees times the perpendicular distance 2 plus this force here is 4 cos of 60 degrees times the perpendicular distance to it, and that distance to this force from B is BF. I've already shown you how we calculate distance BF. You know we wait for the line of action. So the distance BF, this is the perpendicular distance. And you shouldn't cram it. I know you will get 2√3 meters, but you have to show where it comes from. If you just put 2√3, you will not be considered. So I will not go into that again. You let this be y, look for y. So the distance perpendicular to this component is 2√3. the distance BF plus, I'm rotating. That force is done, we go to 2. 2 is clockwise. 2 is clockwise. Rotate clockwise. So it is -2 times the perpendicular distance to 2 is BF, which is again 2 root what? 2 root 3. So this is done. I move on to 1 Newton is force. Some people can resolve it from outside, but I've told you better use the inner point. The components, this is horizontal, this is vertical. The vertical component is not necessary because its line of action is passing through B. So we are left with only this component here, which is 1 cos 60, and about B, it is anti-clockwise. And the perpendicular distance is BF, 2 root 3. So this is going to be plus 1 cos 60 degrees. Perpendicular distance is 2 root 3. Plus, this one has no moment since it is through B. But if you had resolved using this point here, then you have 2 components. So that is done, no moment. We move inside. 3 Newton is force. This 3 Newton is force has this component here and this component downwards. The component downwards has no moment. It's okay. The moment downwards here is what? Is having no moment. This one has no moment, so we have this for 3 and this. This one has no moment, but this one has a moment. So the 3 Newton is force will be 3 cos 60, and which is clockwise. So this will be -3 cos 60 degrees times the perpendicular distance BF, which is again 2 root 3. Yeah, so and the forces are done. So usually when we are doing this, some people give up, others even leave the lesson before the teacher. And when you never set it, they all go in for the question and get only 7 marks out of 12 because they find papers hard and they don't even get chance to interact with their friends. That's why you see now we have 70 people. People have disappeared, but they would like to do the number in case you never set it. So the serious ones will do it and pass. So that's it. We can add on that when we meet next time. But here you get the sum of moments and put it there. Yeah. So you can try last year's number. It was about trapezium. 2019. But now this is different. 120. This is A, that is B, this is C, this is B, D. Here 10 newtons. Then here you can put 2 newtons. Now this is my own. Here you put 30. I was just recalling. And then here 4 newtons. And here 7 newtons. So this cannot be hard in case you get how the distances are calculated here. Now distance. Let this distance be 1 meter. Even here 1 meter. There 1 meter. And then add D to be 2 meters. 1 meter, 1 meter, 1 meter. Get the resultant and where the line of action.
Teacher, is it a Cantab question?
Line AD.
Yes.
Yeah. No, this
is it a Cantab question?
I changed, but if you want, you can try using.
No, he said he's just giving his.
Yeah, you can try using 2019 question, or you can use this. Get the resultant, direction, and where the line of action cuts AD. Where it cuts line AD. So you show me that. Now other lessons will be taught by Mr. Kwa, probability and so on.
Thank you, teacher.
You're welcome.
Bye, teacher.
See you.
Bye.
Thank you, teacher.
Thank you, teacher. Teacher, thank
Lua.
Question. Don't go.
Now, Agava.
Carlton, please first mute and recopy the question. Carlton, please first mute and recopy the question, please. Thank you.
Hello, Adrian. Just pin teacher.
Now, please.
Adrian, just pin teacher.
And may love you.
Lucy, what are you saying?
Now you're then calling me.
Yeah.
Uh-huh.
I'm still saying you send call them.
Okay, let me tell you. I've only, I don't know. I've checked, but I don't have them.
Is it still around?
Okay, you don't have
Oh,
them.
he is curious.
But I'll send by the end of.
You guys, are we supposed to do that?
If we don't have time to do this assignment, we have 1 week and homework.
Mavita, please help send the question. Mavita. Help send the question.
Please try 2019. 2019, you can use 2019.
Which
Please,
number?
if you want to use this here, then this is 1 meter, 1 meter, 1 meter. The question is find the magnitude and direction of the resultant force. And then part B, the point where the line of action of the resultant force cuts side AD.
Yeah.
So this does not work because this is
Mr. Lubega.
Wanji, yes?
Teacher, I wanted to know if we have a rectangle, because most times they give us a square. If we have a rectangle, what angles do we use? I'm confused. Isn't it also 45?
The square, the diagonal makes 45 degrees.
Then the rectangle?
The rectangle, the diagonal, you have to calculate it using the given sides, the length of the given sides. This angle here is 60. Please make sure you send it to them. This is 60, This is 60 degrees.
Chair, please repeat the question.
The question is only this, what you see on the chalkboard. Determine the direction and magnitude and direction of the resultant. Then the line where that line of action of the resultant cuts side AD. That is a 60. I forgot to. So this doesn't work. You have to rearrange.
Teacher.
Because after this, you're supposed to for example, say it's a
Teacher, can I? Teacher? Okay, in motion, linear motion, if they tell you that a particle moves in a straight line with a constant deceleration and then it travels some distance in a certain time, when you're using S is equals to UT plus half AT squared, do you make your A a negative or you ignore that? Teacher, have you had that question?
Teachers, go on. Me, I've had that question.
Yeah, this man is bold. And I called him and he responded. You call him Kobambi.
Just go and sleep.
When you're joking with this teacher, they're not easy.
You call him, please. Tell him it's Adrian.
Are you paying?
Where is
Adeyo?
Yeah. You text him. Don't have his number.
These guys can be screening now. He won't respond.
They screen by the way.
You call, okay, where is Rubana? You just call him.
In the bias lab, teachers in the staff room. You guys
You have to the previous question, please.
put on group, don't worry.
Captain, the previous question also, he rubbed so fast.
Lucy, Agava.
Is anyone going to send their question?
Like how? Like, can I read it for you?
Okay, read the previous question.
Let's start then. Okay, what is the magnitude? 6n, 5n, 4n? You're meaning the first question we did today, right?
Lucy, did you finish that?
Oh, this one he has explained, the one which has a drawing on the board, like the hexagon drawing. That question.
Okay. Okay, let me start. Forces of magnitude 10n, 8n, 6n, 4n, 2n, 3n, and 1n. 10, 8, 6, 4, 2, 3, and 1. Act along sides BA, BC, CD, DE, FE, FC, and FA, respectively, of a regular hexagon of side 2 centimeters. Direction of find that the direction of forces is indicated by the order of the letters. Then determine A, magnitude of the resultant force, B, the inclination of the resultant to side BC. I don't know what that means. Oh, he said we're going to do that next. I don't know. Then part C, the point where the line of action of the resultant cuts side BC.
Repeat from part A. Determine, that's where I've ended now.
Determine A, magnitude of the resultant force. Then part B, the inclination of the resultant to side side BC. I don't know what that means though. Then part C, the point where the line of action of the resultant cuts side BC. Like these normal questions, where the point of line of action, where the line of action of the resultant cuts side BC. Then
part B,
inclination of the resultant to side BC. Teacher, you're back.
Heavens.
Yes.
You say it doesn't matter what to inbox you for the explanations, right?
Yes.
I did. Inbox you for the explanations, right?
It's fine. You can inbox.
Adoyo.
What's your number?
Yes.
What's your number?
Back.
I read.
No, he has got. The guy is rushing to go away. I also do.
No, you can start.
Okay. Wait,
I first going to close the meeting. I want to do the diagram on the board.
Adoyo. Are you the one who records the lessons?
I'm not the one. It's recorded. But it's recorded. It's recording.
Nancy, I don't want to attend that. Okay, I might not attend the chemistry lessons. So I don't know.
You told Mr. Sendaula, where are you going to the weddings?
Yes, you girl. I'm even late.
What happened to the wedding? You told me you had a wedding to attend. What happened?
Nancy, there is a party today and tomorrow. Kati, I'm supposed to be I'm going today. But lesson. But tomorrow I'm going. We have no, you girl, have you done Twaha's work? Wait, are we doing that work like on papers, full scraps?
In your book.
How are we going to hand in our books?
Yeah, on coming day, you sit at the gate, you be there achieving, going for party.
You girl, wait, what about
Mr. Twa has said you write in Champion Brown books, not in your book. He refuses to write in his book.
That you do.
Champion Brown books, those 96 pages.
I say, why does he want
books? If you write in your book, he will not mark, and you know him.
You guys, you're serious? We are collecting that holiday work.
Hey,
we have not yet done anything. Heavens, are you done?
Heavens. There are 66 numbers. If you're not started, you're just dead.
There's so many.
Can't you just do? You have no.
Heavens, how many have you done?
Like Mr. Twaha's work?
Yeah.
I think I'm on number 10, but 1 hour each number.
Let me ask you. I'll do them from school. If they tell you a particle was decelerating, okay, and you're supposed to what? Okay, you're going to use those things of simultaneous equations and stuff. Do you put your A as a negative or you just leave it as normal?
Guys, are you done?
No, not yet. First wait, cook a little.
Even in the remaining money in class.
That's okay.
Eh? I love that.
Joanne, I'm asking.
You ask.
You ask.
If a particle decelerates, okay, they have said it's moving in a straight line with a constant deceleration, then it travels like a distance in a certain time. Then you're going to use S is equals to UT plus half AT squared, right? Now that A, do you put a negative so that you can be having a negative equation, or you're going to leave it as, because I've said it was decelerating, not accelerating.
Put a negative since it's decelerating.
Then if they say it travels, then and after it travels another 20 minutes in the next 30 seconds, do you still leave, okay, do you still use the same deceleration?
It travels what?
They've said, okay, at first it travels like 20 minutes in 15 seconds. Then later it travels another, yeah?
You send me the number, it's Jill, send me the number. Now I find what to do.
Did you buy the modular?
Modular, yeah.
You take number.
Home. I'm here in the lab with these people. So just send a pic of the number, I tell you what to do.
You just come and do the number.
No, like send a pic now, then I do it now.
Like on what?
On WhatsApp. Yeah, I'm waiting.
You talk.
Okay, fine.
Yeah.
Adayo?
Yes.
Adayo?
Yes.
Mechanics, have you tried number 4B?
Number 4B, what's exercise?
The homework, the last part of the homework.
Holiday work. Holiday work.
Yes.
I tell you, girl, my work is at home. Now I don't know.
Did you use that modular book?
No.
Okay, that question, there's a question which is similar in the modular book, and their calculations are confusing me. It has 4G out of tan 60. Now, what does the G represent? And how do you calculate that? That's what confused me.
The G is like acceleration due to gravity.
Marin, I'm waiting for you.
You've got it.
I replace it with 9.8 or 10. I replace it with 9.8 or 10.
9.81, I think. Is it 9.81?
Okay, I'll try and see what answer I get.
Yeah, that one.
Thank you.
Welcome.
You can now close the meeting. I'm done drawing the diagram. Thank you.
Okay.
Yeah.